So let's talk about a function z equal to f of x and y, and such that x is x of t, function of t, and y is y of t. And let's talk about this at a point a and b that are basically a is equal to x of t0 and b is equal to y of t0. We want to show that the chain rule actually holds a little bit more rigorously than shown in the class. In the class, we talk about the dependency tree and so how z is related to x and y, and then x and y both are related to t. So if we take basically find the partials with respect to x and the derivative with respect to t and multiply it together, and then partial respect to y and derivative of y with respect to t and multiply them together, that gives you one way of finding the derivative, the differentials, and the other way gives you the other way of finding differentials, and we add them up. But can we explain this through the definition of the derivative, basically? So the first thing is that, yes, let's say that all the stars are aligned and your functions are differentiable enough at this point, t0 or at point A and B, and go from there. So if, let's say, g of t to be f of x of t and y of t, and so when I'm saying dz dt, I'm finding the derivative of this g of t. So we're finding g prime of t, and g prime of t is the limit as delta t goes to 0 of f of at x of t0 plus delta t and y of t0 plus delta t minus f of x of t0 and y of t0 over delta t. It seems like a lot of writing at this point. I kind of want to make it a little bit more comfortable for me. And so what I'm going to do is replace the this part by a and b. And let's name something. So x at t plus t naught, let's make it x1 and that one to be y1. So now I feel like I can do a little bit better when I have the linearization working in here for me. So I'm going to add and subtract the linearization. So f of x1 and y1 minus the linearization at a and b of x1 and y1. And then I'm going to add that linearization and then subtract f of a and b. Put delta t on both of them, put the limit on both of them. This part actually reminds me of something. If I simplify that, I get f sub x at a and b times delta x plus f sub y at a and b times delta y. That's not bad. Here are more, there's another thing that I can actually see. This is the numerator when we were defining when function of two variable is differentiable. That's the numerator of this limit quotient that was supposed to be equal to 0. So maybe make that limit quotient. And how do we make it? By dividing what I need and multiplying by what I need for the denominator. So keep the numerator. In there, the denominator was the distance between the two, basically the 2 points, A and B, and exponent y1. So the distance is just the, and then delta x to power 2 plus delta y to power 2 divided by delta t. And we decided to write that as it is. Limit delta t goes to 0 of f sub x at a and b times delta x over delta t plus f sub y at a and b delta y over delta t. And so when I bring the limit in, because f sub x of a and b doesn't have, and there's no change in there, it stays the same, it's a constant part, and the limit of this part is going to be x prime of t. The limit of this part is going to be y prime of t. And again, these two pieces are just constant. I put an equal sign, and it means to be a plus. Now, according to the differentiability of f, this section, the limit of this section is going to go to 0. So because the x and y are differentiable with respect to t, I can bring the delta t inside the square root and maybe get this. And I see that there, again, the derivatives show up underneath there if I bring the limit in. And it's going to be a bounded value. So something goes to 0, something is bounded and defined. So I can actually say that this entire first part of the limit is 0. And then what I'm ending up with is just that the second part of the limit, which is limit of delta t goes to 0. And I'm bringing f of x and y out. F sub x of a and b out, delta x over delta t, plus bring the f sub y of a and b out, limit delta y over delta t goes to 0. And this is actually f sub x of a and b times x prime of t 0, and plus f sub y at a and b times times y prime at 0, t0. And that's the solution that we, that actually is the chain rule that we wanted to show.